Find the rate at which its volume is increasing when the radius is 10 centimeters. So the variable diameter is equal to 3 by 2 times 2x plus 1. So dy by dt is equal to 8 by 3. Negative sign indicates it is decreasing. So therefore the marginal revenue is equal to rupees 208. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, the faculty of mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the problems related to rate measure in application of derivatives, finding the rate of change of the area, radius, surface area, radius. Now in this session, I am going to discuss few more problems based on the volumes as well as on the spheres. These type of problems are very important for your final examination. Definitely you will get one 5-marker question from this concept. Now let me start with the first problem. What is the problem? A balloon which always remains spherical on inflation is being pumping 900 cubic centimeter of gas per second. Find the rate at which the radius of the balloon is increases when the radius is equal to 15 centimeters. This is very simple concept. Suppose if a balloon is inflated, a balloon which being filled with a gas of 900 cubic centimeters per minute per second is being inflated. If you inflate, it will take the shape of a sphere. Now here what is given? The volume is given dV by dt, the volume is equal to 900 cubic centimeters per second, cc per second. Now find the rate at which the rate of change of radius is nothing but dr by dt is the question mark. When the radius is equal to 15 centimeters. This is given. What is given? dV by dt is equal to 900 centimeters per second. dr by dt is to be determined, that is required to be determined, and r is equal to 15 centimeters. Now substitute this in a volume. You know the volume of a sphere. Since the volume of a sphere is given by volume of sphere, volume of the sphere V is equal to 4 by 3 pi r cube. The volume of a sphere is 4 by 3 pi r cube. Differentiate with respect to t. Differentiating with respect to t will get dV by dt is equal to 4 by 3 pi constant. Differentiation of r cube is 3r square. dr by dt we are differentiating with respect to t. Now substitute the values. Cancel this 3 and 3 gets cancelled. Substitute what is dV by dt? 900 is equal to 4 pi into what is r? R is equal to 15 centimeters. 15 square into dr by dt. That's it. Now simplify. The rest is the simplification. So 900 is equal to 4 pi into 15 square. 15 into 15. So this is equal to 15 into 15 is nothing but 225 into dr by dt, or only dr by dt is equal to 900. Bring this to the denominator. 225 into 4 is again this is 900 pi. So 900 gets cancelled. You will get 1 by pi. dr by dt is equal to 1 by pi. So since dV by dt is 900 is equal to 4, 3 and 3 gets cancelled. 4 pi into r square is 15 square. 15 square is 225. 225 into 4 is 900. So 900 divided by 900 pi. 900 gets cancelled. 1 by pi. So what is the unit? Therefore dr by dt is equal to 1 over pi. What is the unit? Cubic centimeters. So dr by dt is equal to centimeters per second. So dr by dt is equal to 1 by pi centimeters per second. This is the required answer. That means find the rate at which the radius, the rate of change of radius is 1 over pi times centimeters per second is the required answer. Hope you followed this. Now let us come to the next problem. Same type problem. What is the problem given? A balloon, same balloon problem. A balloon which remains spherical has a variable radius. Okay, let's come to the next problem. What is the next problem? A balloon which remains spherical has a variable radius. The variable radius. Find the rate at which its volume is increasing when the radius is equal to 10 centimeters. Now let us consider, let V is the volume, V be its volume, and R is the radius, R be its radius. Now what is the volume of a sphere? V is equal to 4 by 3 pi r cube. Now what is given? Given that the radius is equal to 10 centimeters. Radius is equal to 10 centimeters. What is required to find is dV by dr. dV by dr is to be determined. dV divided by dr. Now differentiate this with respect to r. Differentiating with respect to r, dV by dr is equal to 4 by 3 pi constant. Differentiation of r cube is 3r square. We are differentiating with respect to r, not with respect to t. In the previous problem, we have differentiated with respect to t. Now, this is with respect to r, 3 and 3 gets cancelled. What is remaining? 4 pi into, substitute the value of r. What is r? R is equal to 10 square. This is 4 pi into 100. This is 400 pi. This is the required answer. So, therefore, the required answer is 400 pi. Since it is, what is the unit given? Centimeters. Since this is the volume, so the volume is equal to 400 pi. Now, since what is the unit given? Centimeter. This is the volume. So, therefore, the required unit for this is 400 pi centimeter cube per centimeter. Centimeter cube per centimeters. So, what is the problem here? A balloon which remains spherical has a variable radius. Find the rate at which its volume is increasing when the radius is 10 centimeters. Now what is given? R is equal to 10 centimeter, the radius, and what is required to find is dV by dr. So the rate of change of volume with respect to the radius. So we know the formula for volume of a sphere, 4 by 3 pi r cube. Differentiate with respect to r, dV by dr is equal to 4 by 3 pi into differentiation of r cube is 3r square, 3 gets cancelled, 4 pi into r is equal to 10 square, that is 4 pi into 100 is 400 pi. Since the unit is centimeter cube per centimeter because it's the volume. So therefore the rate of change of volume is 400 pi centimeter cube per centimeters. This is the required answer for this problem. Now let us come to the next problem. What is the next problem here? Again a balloon problem. A balloon which always remains spherical has a variable diameter. The first problem it was radius, now it is diameter. So the variable diameter is equal to 3 by 2 times 2x plus 1. This is given. Find the rate at which its volume is increasing, volume with respect to x. What is required to find is dV by dx is the question mark. That's it. So a balloon which remains spherical, whenever if you compress, it will come to the spherical shape. So a balloon which always remains spherical has a variable diameter. Diameter is 3 by 2, 3x plus 1. Find the rate at which its volume with respect to x. So what is required to find is dV by dx. This is the problem. Now let us solve this. Now what is given? Given diameter is equal to 3 by 2, 2x plus 1. Now since what is the radius? Radius is equal to diameter divided by 2. Now this is half of 3 by 2 into 2x plus 1. Therefore the radius is equal to 3 by 4 times. This is 2x plus 1. 2x plus 1. Now, since you know the volume of a sphere is given by volume V is equal to 4 by 3 pi r cube. Substitute here 4 by 3 pi into, what is r? This is the value of r. R is equal to 3 by 4 into 2x plus 1 whole cube. Now this can be written as 4 by 3 pi into 3 by 4 whole cube into 2x plus 1 whole cube. Now therefore v is equal to, you can cancel 1, 3, 3, 4, 4 gets cancelled. You will get 3 square is 9, 4 square is 16. 9 by 16 times pi into, what is remaining is 2x plus 1 whole cube. Now differentiate this with respect to x. Now differentiating with respect to x, we will get dv by dx is equal to 9 by 16 pi is a constant, and derivative of this is 3 into 2x plus 1 whole to the power of 3 minus 1 is 2 into differentiation of 2x is equal to 2. Now this can be written as, how to simplify this? So divide this, 2 into 8, 8 times it will get cancelled. Now this is equal to dv by dx is equal to 9 by 8 times pi into 3 times 2x plus 1 whole square. So this can also be 9 3s are 27. 27 pi divided by 8 times 2x plus 1 whole square is the simplified answer. 27 pi divided by 8 into 2x plus 1 whole square is the required answer for this problem. So that means the rate of change of volume with respect to x, the rate of change of volume with respect to x is given by dv by dx is equal to 27 pi by 8 into 2x plus 1 whole the square. That's it. We will explain once again. A balloon which always remains spherical has a variable diameter. What is given? Diameter is equal to 3 by 2 into 2x plus 1. So convert the diameter to radius. Since radius is equal to diameter divided by 2, radius is d by 2, half of 3a by 2 into 2x plus 1 is 3 by 4 into 2x plus 1. Since we know what is required to find is the rate of change of volume with respect to x is dv by dx is to be determined. Since we know the volume of a sphere 4 by 3 pi r cube, 4 by 3 into pi times, substitute the value of r is equal to radius 3 by 4 into 2x plus 1 whole cube. This is 4 by 3 pi into 3 by 4 whole cube into 2x plus 1 whole cube. 1, 3, 3 and 4, 4 gets cancelled. What is left over is 3 square. 3 square is 9 in the denominator, 4 square is 16. 9 by 16 times pi into 2x plus 1 whole cube. Differentiate with respect to x because we want to find out dv by dx. Now differentiating with respect to x, dv by dx is equal to 9 by 16 pi constant as it is, f of x to the power of n. N is 3 times 2x plus 1 to the power of 2 minus 1 is 3 minus 1 is 2. 9 by 16 pi into 3 times 2x plus 1 whole square into differentiation of 2x is 2. So cancel, 2 8s gets cancelled. So again 9 3s are 27 divided by 8, 27, yes, 27 by 8 pi into 2x plus 1 whole square is the required answer. Therefore, the rate of change of volume with respect to x is given by dv by dx. dv by dx, the rate of change of volume with respect to x is dv by dx is equal to 27 pi divided by 8 times 2x plus 1 whole the square. This is the required answer for this problem. Okay, hope followed. These are all very important and easiest problem. All these problems based on the same formula, volume of the sphere 4 by 3 pi r cube. Now let us come to the next concept. What is the problem given? A particle moves along the curve. This is also important for 5 marks. A particle moves along the curve 6y is equal to x cube plus 2. Find the point on the curve at which y coordinate is changing 8 times as fast as the x coordinate. This is very important problem indeed. So a particle moves along a curve. What is given? The curve is given 6y is equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. So y coordinate means dy by dt is changing 8 times as fast as the x coordinate. This is the condition given. Dy by dt is equal to 8 times dx by dt. Now differentiate this with respect to t. Differentiating with respect to t, what you will get? 6 into dy by dt is equal to differentiation of x cube is 3x square. We are differentiating with respect to t, dx by dt plus 2 constant, derivative of a constant is 0. Since what is the condition given? Dy by dt is equal to 8 times dx by dt. 6 into substitute dx by dt is equal to 8 times dx by dt is equal to 3x square into dx by dt. So this dx by dt gets cancelled, divide by dx by dt. So dx by dt and dx by dt on both sides gets cancelled. What is remaining? 6 into 8, 48 is equal to 3 times x square. Only x square is equal to 48 divided by 3. So what is this equal to? This is nothing but 16. So therefore x is equal to square root of 16 is plus or minus 4. So thus we are going to get one value of x. Now substitute this value of x in equation. 6y is equal to x cube plus 2. You will get the points. That's it. Very simple problem. See here. A particle moves along the curve 6y is equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Given 6y is equal to x cube plus 8, and very important condition given is dy by dt is equal to 8 times dx by dt. Differentiate this, differentiating with respect to t. 6 times dy by dt is equal to differentiation of x cube is 3x square dx by dt. 6 into, since dy by dt is equal to 8 times dx by dt is equal to 3x square dx by dt, divide by dx by dt gets cancelled. 6 into 8 is equal to 3x square. 48 is equal to 3x square, therefore x square is equal to 48 by 3. That is 16, x is equal to plus or minus 4. So the value of x is plus or minus 4. Substitute this value of x in equation number 1, you will get the y coordinate. That's it. That is the problem. I'll go to the next page. I'll rub this and go to the next page. Now, next, when x is equal to plus 4 and when x is equal to minus 4, substitute here. So that is, when x is equal to 4, 6y is equal to x cube, 4 cube plus 2. Now 6y is equal to 4 4s are 16, 16 4s are 64 plus 64 plus 2. This is equal to 66. Therefore y is equal to 66 by 6 is 11. Therefore the first point is when x is 4, y is 11. Now come to the second point. When x is equal to minus 4, 6 into y is equal to minus 4 whole cube plus 2. 6y is equal to minus 4 whole cube is minus 64. Minus into minus into minus plus. Minus into minus plus into minus minus. 6 4 4s are 16, 16 4s are 64 plus 2. 6y is equal to minus 62. Y is equal to minus 62 by 2. So this can be divide by 2 minus 31 divided by 3. Minus 31 divided by 3. 2 3s are, 2 1s are, 2 2s are. Yes. Now therefore the other point is, what is the other point? When x is minus 4, y is equal to minus 31 by 2. So therefore the points are, first point is 4 comma 11 and another one is minus 4 comma minus 31 by 3. These are the points. So the points are 4 comma 11 and minus 4 comma minus 31 by 3 are the required points. Okay. So from the previous page, substitute the value of x plus or minus 4. When x is plus 4, y is equal to 11. When x is equal to minus 4, y is equal to minus 31 by 3. Therefore the required points are 4 comma 11 and minus 4 comma minus 31 by 3. That is regarding this problem. Okay, come to the next problem. What is the problem? A ladder 5 meters long is leaning against a wall. This is a wall. Now let us consider this is the ground and this is the wall and ground. Okay. Now a ladder 5 meters long is leaning against a wall. This is the ladder. Let us come to this. This is the ladder. This is the ladder. What is that height? Height is equal to 5 meters. This is given. So a ladder 5 meters long leaning against a wall like this. The bottom of the ladder is pulled along the ground. If this is the bottom, let us consider this as X and this is Y. If X is pulled towards, if it is pulled away from the wall at the rate of 2 centimeters, 2 meters, that means dx by dt is equal to 2 meters per second. How fast is the height of the wall decreasing? That means dy by dt is to be determined when the foot of the ladder is 4 meters. That means when x is equal to 4 meters. This is the problem given. See here, a ladder 5 meters long is leaning against the wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 meters per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? Very simple. This is the ground, this is the ground, and this is the wall, and a ladder is leaning like this. The height is equal to 5 meters. Let us consider the distance x from the ground, that is from the wall to the ground is x again, and y is the height. Now here let us call it as, let us consider this as A, B and C from right angle triangle. So what is given? Dx by dt is equal to 2 meters per second. Dy by dt is to be determined. X is equal to 4 meters. Now very simple. From triangle, from right angle triangle, from triangle ABC, this is 90 degrees from right angle triangle. From right angle triangle ABC, if you apply Pythagoras theorem, what you will get? AC square is equal to AB square plus BC square. Now what is AC square? Phi square is equal to AB. What is AB? Y square plus BC is equal to x square. So that is x square plus y square is equal to 25. Now let us represent this as equation number 1. When x is equal to 4 meters, when x is equal to 4 meters, find, substitute here. Y square can be written as 25 minus x square. So y square is equal to 25 minus x is equal to 16. 4 square is 16, that is equal to 9. So therefore y is equal to plus or minus 3. Y is equal to 3. Now therefore consider the value of y as positive. Y is equal to 3 and x is equal to 4. Now from this, substitute here. Now from this equation, from 1, I will go to the next page. From 1, x square plus y square is equal to 25. Differentiate this. Differentiating with respect to t, what you will get? 2x into dx by dt plus 2y into dy by dt is equal to, differentiation of constant is 0. Substitute the value of 2 into, what is x here? X is equal to 4, y is equal to 3, x is equal to 4 into dx by dt. What is dx by dt? 3, it is 2 plus 2 into, what is y? Y is equal to 3 into dy by dt is equal to 0. Okay, from the previous page we got x square plus y square is equal to 25. Differentiating with respect to 2x dx by dt plus 2y dy by dt is equal to 0. 2 into x is 4, dx by dt is 2, 2 into y is 3, dy by dt is to be determined. So this is 4 to the 8 to the 16, 4 to the 8, 8 to the 16, 2 3 is 6 into dy by dt is equal to 0. Therefore 6 times dy by dt is equal to minus 16, or dy by dt is equal to minus 16 by 6. This can be written as minus divided by 2. If you divide by 2, 2 3s are and 2 8s are 8 by 3. So dy by dt is equal to 8 by 3. Negative sign indicates it is decreasing. So minus indicates it is decreasing. Therefore, the required answer is dy by dt is equal to 8 by 3. What is the unit? Since that means how fast is the height of the wall? So the rate of change, that is how fast is the height? The height of the wall is decreasing at the rate of the height of wall is decreasing at the rate of 8 by 3. It is decreasing at the rate of 8 by 3. What is the unit? Centimeters per second. Centimeters per second. The unit is 8 by 3 So negative sign indicates it is decreasing. Therefore, it is decreasing at the rate of 8 by 3 centimeters per second. This is very important problem indeed. Let us come to the next problem. Sand is pouring from a pipe. Suppose if you are pouring sand from a pipe at the rate of 12 centimeter cube per second, the falling sand forms a cone. So the falling sand will form a cone. This is the cone. It will form a cone. Okay. On the ground in such a way that the height of the cone is always 1/6 of the base. So the height of the cone is always 1/6. 1/6 times the base. The height is equal to 1/6 times the base. How fast height of the sand cone increasing when the height is equal to 4 centimeters. So when the height is equal to 4 centimeters, how fast the height of the sand cone is increasing when the height is equal to 4 centimeters. So you can write like this or inverted cone also. Now this is very important problem for 5 marks. Now let us write down the formula for volume of a cone. What is the volume? (1/3 pi r square h). The volume of a cone is 1/3 pi r square h. Suppose if r is the radius, let r is the radius and h is the height of the cone, then the volume of a cone is v is equal to 1/3 pi r square h. Now suppose if r is the radius, then what is the given condition here? H is equal to 1/6 times the base, means r 1/6. So h cross multiply it. If you cross multiply, what you will get? So r is equal to 6h we are going to get. Substitute and simplify. Since this is a function of two variables r and h, so obtain the relation between r and h by substituting the value of r. We will get, therefore, what is given here? dv by dt is given. dv by dt is equal to 12 centimeter cube per second, and what is required? The height of the sand when height is equal to 4 centimeters. H is equal to 4 centimeters. Now substitute here, v is equal to 1/3 times pi into, substitute the value of r. What is r? R is equal to 6h square into h. Therefore v is equal to 1/3 times pi into 36 h square into h. So this can be written as 36 divided by 3, 3 ones are 3 2s are, this is pi into 12 times h cube. This is nothing but 12 pi h cube. V is equal to 12 pi h cube. Differentiate, you will get the answer. That's it. Now listen to me. Just I'll explain once again. Now that is, since what is given? Sand is pouring from a pipe at the rate of 12 centimeter cube per second. That is, dv by dt is equal to 12 centimeter cube per second. The falling sand form a cone on the ground in such a way that the height of the cone is always 1/6 of the base. The height is equal to 1/6 of the base. Therefore, h is equal to 1/6 times r. So r is equal to 6h. Now the sand, how fast is the height of the sand cone is increasing when the height is equal to 4 centimeters. So what is required to find is dh by dt. dh by dt is to be determined. Since we know the volume of a cone is 1/3 pi r square h, 1/3 pi into, since h is equal to 1/6 times r, this is the given condition, cross multiply, r is equal to 6h. Substitute here, because this is a function of two variable, obtain the relation between r and h like this, r is equal to 6h. Substitute here, that is 6h whole square into h is 36h square into h is 36 by 3 is 12. So therefore v is equal to 12 into h cube. Now differentiate this with respect to time t, you will get the answer. That's it. Now differentiating with respect to t, I will go to the next page. V is equal to, what is v? 12 pi h cube. Okay, this is the value of v. Now differentiating with respect to t, what I will get? dv by dt is equal to 12 pi constant, differentiation of h cube is 3h square into dh by dt. Now substitute the value of dv by dt. dv by dt is 3 and h is equal to 4. dv by dt is 12. So dv by dt is 12. 12 into pi into h. What is h? H is nothing but 4. So 4 square into dh by dt. So 12 and 12 gets cancelled. 1 is equal to pi into 3 into 4 4s are 16 dh by dt. So only dh by dt is equal to 1 divided by 16 into 3, 48 pi, 1 over 48 pi. So therefore dh by dt is equal to 1 over 48 pi, 1 over 48 times pi. So therefore dh by dt is equal to 1 over 48 times pi. What is the unit? So the unit for this is centimeters per second. So dh by dt is equal to 1 over 48 times pi centimeters per second. Let me see what is that. Therefore the height of the cone sand cone is increasing at the rate of dh by dt is equal to 1 over 48 times pi centimeters per second. This is the required answer. 1 over 48 times pi centimeters per second. That is the required answer. Okay. Now let us come to the next problem. Now what is the problem given? The total revenue in rupees, received from the sale of X unit of a product is given by Rx is equal to 13x square plus 26x plus 15. Find the marginal value when the value of X is equal to 6. So the total revenue, what is the total revenue? R of X is 13x square plus 26x plus 15. This is given. Find the marginal value, marginal revenue. Let us call it as MR, marginal revenue when X is equal to 7. The revenue Rx is given by 13x square plus 26x plus 15. Therefore, the marginal revenue, so the marginal revenue MR is given by d by dx of this R. That is nothing but d by dx of 13x square plus 26x plus 15. Marginal revenue is equal to d by dx of R. That is nothing but d by dx of 13x square plus 26x plus 15. Differentiating with respect to x, 13 into differentiation of x square is 2x plus 26 into differentiation of x is 1. 13 2s are 26, 26x plus 26. Now substitute the value of x. X is equal to 7, then this becomes 26 into 7 plus 26. What is this equal to? So this is 182 plus 26 is equal to 208. So therefore the marginal revenue is equal to rupees 208. The marginal revenue is rupees 208. This is the required answer. Followed. Now listen to me. What is given? Rx. R of x is nothing but the revenue in rupees is given by 13x square plus 26x plus 15. Differentiate with respect to x to get the marginal revenue. MR is equal to d by dx of R, that is 13x square plus 26x plus 15. Differentiate with respect to x. So you will get differentiation of x square is 2x, 13 constant, 26 into 1. So 26x plus 26, when x is equal to 7, you will get 182 plus 26 as 208. Therefore, the marginal revenue is rupees 208. This is the required answer. So these are few problems based on the rate measure. Okay. Now this is very important type of problems. You may expect 1 3-mark questions or 5-mark question. So hope you followed this. That's all for the day. Let us meet in the next class with a different concept. That's all for the day. Thank you very much. Thank you.